In this video, I am going to prove that for every integer n, if n squared is even, then n is even. And I'm going to use a proof by contrapositive, or proof by contraposition. So we're going to suppose that n is odd. Thus, n would be equal to 2k plus 1, with k being an integer. So, by substitution, n squared will equal to 2k plus 1 squared, which we could then multiply that out to make 4k squared plus 4k plus 1 by algebra. So now we could factor a little bit. Which would mean that this implies that 4k squared plus 4k plus 1 could equal to, we could factor out a 2 from both of these first two terms. 2 times 2k squared plus 2k plus 1. Which would be by the distribution rule. Thus, since the integers are closed under addition and multiplication, then we can let g is equal to 2k squared plus 2k, where g is an integer. Thus, n squared will be equal to 2g plus 1 and by the definition of an odd number, n squared now is odd. So now, because we show that n squared would then be odd there, we now have therefore for every n that's an integer, n squared, if n squared is even, then n is even by a proof by the contrapositive or contraposition.